Welcome back to another episode of Mysterious Geometry Podcast. I'm glad you could join me. Today we're going to continue with inequality proofs. Okay. The proof that we have on the board is a fairly straightforward proof, but it's kind of interesting because there's a couple of moving parts in here. What we're using this time is the triangle inequality that states that any one side of a triangle has to be shorter than the sum of the other two sides. Makes perfect sense if you think about it a little bit. And here we're going to see how it's employed in a proof. So we're given a triangle with a point D on side BC. Okay, that's really just describing the picture to us. And then we have AD equal to DC. Well, again, it's hard to mark AD equal to DC, but we can say that they're congruent in the picture so we know what's going on. So we have AD equal to DC, which means that that segment is congruent to that segment. Okay. We want to prove that AD is less than BC. So we want to say that this side is less than this side. Well, in order to do that, you want to think about what you know AB is less than. Right? We're not given a statement about an inequality here. So if you're going to end up with an inequality, somewhere along the line you have to get one. We're going to use the triangle inequality to do it. So if you look at side AB, it's part of two different triangles. The trick here is to notice that the triangle you want is the smaller one. With this triangle inequality, we can say that AB has to be less than BD plus AD. Right? Because this is a triangle. ABD is a triangle. So this side obviously is the shortest distance between these 2 points. That means that going AD and then DB is a longer distance. It's going to take more time. So AB has to be less than BD plus DA. So why don't we start there? We can say in step 2 that AB must be less than BD plus AD. BD plus DA. And our reason for that is the triangle inequality. Again, triangle inequality tells us the length of any one side of the triangle has to be shorter than the sum of the other two sides. So we know now that AB is less than BD plus AD. How do we get to say that AB is less than BD plus DC? Oh, I slipped a little there. I gave it away. We want to say that AB is less than BC, right? This whole side? Well, isn't BC just BD plus DC? Right? So if we could say that AB was less than BD plus DC, we'd be in business. Well, we can say that, right? How can we get this to be AB less than BD plus DC? Well, we just substitute. Look here. AD is equal to DC. If they're equal quantities, then that means I can substitute them, right? So, and we're going to rewrite this line, but instead of AB less than BD plus DA, now we're going to say AB is less than BD plus, I'm going to replace DA with DC. My reason for this is substitution of inequalities. Substitution, inequality, and like any substitution, you're going to tell me steps. So in this case, nice and simple, steps 1 and 2. Well, we're actually just about done. We now know that AB is less than BD plus DC. We'd like to say that AB is less than BC. Well, isn't BD plus DC the same as BC? What postulate tells us that? That's right, partition. So in step 4, we're going to come in here and say, well, BD plus DC, that's exactly the same thing as BC. That's a partition step. And now we really are basically done. We want to say AB is less than BC. We know that AB is less than BD plus DC. And now we know that BD plus DC is equal to BC. So one more substitution, we're done. In step 5, we're going to say AB less than BD plus DC. Well, now we're going to replace BD plus BC with BC. And that is one more substitution of inequalities. Again, steps. What am I using? Steps 3 and 4. And there you have a nice simple triangle inequality proof. So I hope that helps. If you have any questions or there's something else you'd like to see me do, either send me an email or if you're in my class, just stop by and let me know after class. I hope this helped. Thanks as always for watching and have a great night.